Welcome to Meteorology Matters. You know, sometimes the quietest moments in nature, well, they're the most intriguing, aren't they?
They really can be.
Right now, we're deep into hurricane season, but the Atlantic,
Mm.
it's seen this curious lull. On the surface, it feels almost deceptively calm.
Deceptive is a good word for it.
But what does that silence truly mean when you actually look beneath the surface? Is it a genuine break? Or maybe just the quiet before something, well, something bigger?
That's the million-dollar question, isn't it?
Yeah.
And it's a crucial distinction we really need to dig into. While that recent calm might feel like a welcome breather for a lot of people, especially along the coast,
Sure, yeah.
the underlying conditions, they tell a much more dynamic and, frankly, uh, a pretty concerning story.
Concerning how?
We're observing some really significant shifts developing, in the ocean and the atmosphere right now.
Yeah.
Shifts that could dramatically shape the rest of this hurricane season, and maybe even influence weather patterns well beyond that. It's a classic case of appearances being deceptive in meteorology, and it definitely needs our focus.
Exactly. And that's precisely why we're here today on Meteorology Matters. We're going to pull back the curtain on this tropical update, connect it to some broader conversations happening in weather science.
Which are pretty interesting in themselves right now.
Absolutely. And then we'll look ahead at what future weather patterns, specifically the potential return of La Niña, might mean for all of us as we head into the colder months.
Right, connecting the dots.
Our mission, as always, is to give you, our listener, a clear, informed, and really in-depth picture of these powerful forces at play in our atmosphere and oceans, and ultimately what that means for you. So let's unpack this fascinating puzzle.
Let's do it.
Okay, so let's start with this quiet period in the Atlantic. It's been, at least 15 days, a full 2 weeks since the last tropical storm was out there?
That's right, a noticeable gap.
That feels like a pretty significant quiet spell, wouldn't you say? Especially for this time of year. I mean, the historical data usually points to more action now.
It is indeed remarkable, a notable quiet spell, especially when you stack it up against the historical averages for this point in the season. Typically, by early September, which, we often think of as the climatological peak,
Right, the peak.
we generally expect to have seen around 8 named storms across the basin.
8.
This year so far, only 6 named storms.
So 2 behind average already.
Exactly. And the difference gets even more pronounced, maybe even more telling, when you look at hurricanes. Historically, by now, we usually have seen 3 hurricanes.
3 hurricanes by early September.
But this year, only one of those 6 named storms, Hurricane Erin, actually managed to reach hurricane strength.
Just Aaron.
Just Erin. So, yeah, the raw numbers definitely show a quieter start in terms of named systems. We're well behind schedule compared to an average season.
So on the surface then, it looks like a much quieter start than usual. Fewer named storms, fewer hurricanes. But the big question is, does that really tell the whole story? Or, like you hinted, is there something more significant, maybe more potent, brewing underneath this calm that we need to be watching?
Not at all. It doesn't tell the whole story. And,
Yeah.
and this is precisely where digging into the meteorological data becomes absolutely critical.
Yeah.
Despite that recent lull in storm formation we just talked about,
Yeah.
the research clearly shows that water temperatures across a huge portion of the Atlantic basin, all through the Caribbean Sea, and particularly within that contained basin of the Gulf of Mexico,
And Gulf, yeah. Always a key area.
they haven't just stayed warm. They've continued this relentless climb. In many of these areas, especially those really sensitive zones for tropical development, these temperatures are actually at record high levels for this time of year.
Record highs.
Record highs. This isn't just a small fluctuation or, a blip in the data. It represents this deep, pervasive warmth, a truly exceptional heat anomaly that's been building for months.
And when you say record high levels, are we talking what kind of temperatures?
We're talking ocean temperatures pushing near 90 degrees Fahrenheit in significant parts of the Gulf of Mexico and the southwestern Atlantic.
90 degrees, wow. That's well above the 80-degree threshold usually needed for storms to even get going.
That's right. Way above that roughly 80-degree Fahrenheit minimum surface temperature needed to sustain the convection, the thunderstorm activity that's vital for tropical storm generation.
It really sounds like we've got this, superheated bathtub out there, a massive energy reservoir just waiting.
Your analogy of a superheated bath is remarkably accurate, spot on. And while those surface temperatures are undeniably crucial, what's truly critical and maybe less understood by the public is what meteorologists call the ocean heat content.
Ocean heat content. Okay, what's that
So
exactly?
it's not just about the very top layer of the water, the skin that warms up quickly in the sun. It's about how warm the water is extending down, sometimes hundreds of feet, maybe even 1,000 feet below the surface.
Ah, the depth of the warmth.
Exactly. And this year, the ocean heat content in the Gulf of Mexico specifically isn't just high, it's at record high levels. This exceptional warmth penetrating deep into the ocean column, that's particularly concerning
Why is that deep warmth so much more concerning than just hot surface water?
because it represents this vast, essentially inexhaustible reservoir of thermal energy. It's the ultimate fuel tank for a developing storm.
Okay, that deep warmth sounds like a really significant factor, almost like this hidden engine driving potential storm power. Can you maybe elaborate a bit more on why that deep ocean heat content is so critical? Not just for getting a storm started, but maybe for how strong it can get.
It is absolutely critical, and here's why it needs our full attention. When the water is warm deep down, not just at the surface,
Right.
it provides this continuous, readily available fuel source for any tropical system that forms or moves over it. Think of it like this. A hurricane gets its energy from releasing latent heat when water vapor, evaporated from that warm ocean surface, condenses. Now, if the surface water is warm, but the layers underneath are cool, a strong storm can actually churn up that cooler water from below.
And that weakens it.
Exactly. It effectively cuts off its own fuel supply and weakens itself. It's a natural break. But with deep, warm water, a storm can mix the ocean really vigorously without hitting those cooler layers.
Ah, so no break.
No break. This deep warmth is crucial because it helps tropical systems not just intensify, but rapidly intensify. It lets them draw immense amounts of energy from the ocean without any hindrance.
Rapid intensification. We hear that term a lot, and it always sounds scary.
It should sound scary. And this deep heat makes them far less likely to weaken once they've formed, even if they hit, say, a temporary patch of atmospheric resistance like some wind shear.
They can just power through it.
They can maintain their strength or even keep growing because that deep, warm water acts like this inexhaustible battery, constantly recharging the system. It creates a much more robust, resilient, and potentially devastating storm. It makes it possible for storms to become major hurricanes in a shockingly short time.
So, if a storm does manage to develop in a place like the Gulf of Mexico, with that record high ocean heat content, you're basically saying there's significantly less time for people on the coast to get ready for its full impact.
Precisely.
The strengthening could be so quick that the window for evacuation, boarding up, all that stuff, it just shrinks dramatically.
That's one of the most critical and dangerous aspects of having record ocean heat content in regions like the Gulf. Rapid intensification means a storm can ramp up from, say, a relatively minor tropical depression or tropical storm to a powerful, even a major hurricane in a very short period, sometimes less than 24 to 48 hours.
Less than 2 days. Wow.
Yeah, and that dramatically compresses the timeline for emergency managers to issue warnings, for residents to make those critical life or death decisions, and for communities to actually implement their preparedness plans. You get significantly less preparation time compared to storms that strengthen more gradually way out in the central Atlantic.
That difference in lead time, that
Yeah.
could be everything.
It can literally be the difference between life and death,
Right.
or between huge property damage and more manageable impacts. It's a
Yes.
critical distinction. And it really underscores the need for constant vigilance and proactive year-round preparedness, especially in coastal communities near these warm water bodies.
So the speed is the real killer here.
The speed with which these systems can change means every single moment counts. Early action is absolutely paramount.
Okay, so we've established this. We have exceptionally warm water, especially that deep ocean heat content just sitting there, primed, ready to go.
But yeah,
But despite that, we've had this lull in activity recently. So the natural question is, what exactly has been holding back these potential storms? What's been the atmospheric resistance, as you put it, that's been counteracting all that ocean energy?
that's the other crucial half of this complex weather equation.
Yeah.
And it really is like a delicate atmospheric dance. For the past couple of weeks, we've seen this vast, persistent zone of dry air, often full of dust.
Saharan dust, right? We hear about that.
Exactly. Saharan dust is a big player. And that's been coupled with extensive areas experiencing what we call combative winds, or more commonly, wind shear.
Wind shear, okay.
These two things, dry air and wind shear acting together, have largely functioned as powerful suppressors. They've effectively hindered tropical development and stopped any significant storm from really taking hold or rapidly intensifying.
Like a lid on a boiling pot.
That's a great way to put it. A strong, persistent lid on top of that superheated ocean, keeping the potential energy bottled up.
And where is this dry air coming from? Is it just hanging out over the Atlantic, or are there bigger weather patterns pushing it in?
Oh, it's definitely part of a broader intercontinental pattern. Much of this dry air has originated from distinct places. We've seen significant plumes of dry, dusty air coming all the way from the Sahara Desert and traveling across the Atlantic,
All the way from Africa.
all the way from Africa. Plus, we've also had dry air masses from Canada getting pulled into the circulation over the Atlantic.
Okay, so multiple sources.
And adding to that, the overall circulation around the big central Atlantic high-pressure system.
The Bermuda High, sometimes.
Sometimes, yeah. That, along with another large high-pressure zone sitting over the eastern United States, has played a big role. These high-pressure systems create strong upper-level winds, and those winds contribute to and maintain that strong wind shear.
Right, the wind shear. Can you break that down simply? What does it actually do to a storm?
Sure, wind shear is essentially a rapid change in wind speed or direction as you go up higher in the atmosphere. Strong wind shear literally rips apart the vertical structure of a developing tropical system. It tilts its central column.
Tilts it.
Yeah, imagine trying to build a tall tower of blocks,
Yeah.
and the wind keeps blowing harder and from different directions as you build higher. It just knocks it over. It prevents that crucial heat engine from getting organized into a sustained symmetrical circulation. It basically shreds the storm before it can get strong.
Okay, that makes a lot of sense. So you have these two big opposing forces. The ocean trying to fuel the storms, and the atmosphere with dry air and shear trying to tear them apart.
Exactly, a tug of war.
But these atmospheric conditions, they aren't static, right? They don't just stay the same all season long. Things change.
They are absolutely not static. In fact, they're notoriously dynamic. And this is exactly why our vigilance becomes even more critical for the coming weeks. The latest research, the weather models we look at, they indicate that these atmospheric conditions, the ones that have been so good at suppressing storms, are expected to change significantly.
How soon?
We're expecting much more conducive conditions for tropical development. That means less wind shear, less dry, dusty air.
Yeah,
And this could return as early as next week.
next week.
And remember, as we just spent time discussing, all that very warm water, that deep record-level ocean heat content, it's still sitting there,
Wait.
fully charged and ready to be tapped.
So the atmospheric lid is about to come off.
It looks like it. This imminent shift in the atmosphere means that the brakes on tropical activity could be easing very soon, paving the way for a potentially rapid increase in storm formation and strengthening.
Wow. That sounds like a recipe for a significant increase in activity, especially with all that energy just stored up in the ocean. As forecasters, is there one area, maybe, of particular concern that you and your colleagues are watching really closely as these conditions start to shift?
There is, yes. One zone in particular really demands our heightened attention right now. It's the region stretching from the western part of the Caribbean Sea northward into the entire expanse of the Gulf of Mexico.
Western Caribbean and the Gulf. Okay.
This area has historically been a hotbed for tropical activity. We often see storms develop there early and late in the season. But honestly, it's a region where development can happen anytime if the conditions are right.
And conditions might be getting right soon.
With the anticipated easing of wind shear and less dry air, combined with that extreme record-breaking ocean warmth we talked about.
Yes. This area becomes a prime candidate for future tropical development. And, critically, for rapid intensification.
And storms forming there are closer to land, less warning time again.
Exactly. That geographic area is also concerning because storms developing there can threaten heavily populated coastal areas with significantly reduced warning times compared to storms forming way out east.
We also saw Hurricane Erin earlier this season just explode into a Category 5 storm in less than 25 hours, didn't we?
We did.
That was just astonishing and terrifying. It feels like a really stark preview of what could happen if these conditions line up again, that deep ocean heat and easing atmospheric suppression.
You're absolutely right to bring Erin up. That rapid intensification event was a stark, powerful, and truly sobering illustration. It showed precisely how favorable atmospheric conditions, when they combine with that deep, warm water, can fuel an incredibly fast and dramatic increase in storm strength.
From tropical storm to Cat 5 in under a day. Yeah, it's rare, it's extreme, and it's exceptionally dangerous. It's a vivid reminder of the immense potential for strength when all the pieces align. And it's why the current forecast for easing atmospheric suppression layered on top of the existing widespread record ocean heat is so concerning for the upcoming weeks.
It really highlights how volatile these systems can be.
And unpredictable sometimes. It really underscores the need for preparedness.
It puts things into perspective, too. These aren't just isolated weather events, are they? They're part of this much larger global system trying to balance heat across the planet.
Precisely.
And as that system gets more energized by these incredibly warm oceans, the potential for these really strong, rapidly intensifying, devastating events just goes up. It feels like the whole engine of weather is running hotter.
That's a very good way to think about it. It's vital to remember that depressions, tropical storms, hurricane systems, they play a fundamental, integral role in Earth's massive atmospheric engine. Their primary job in this grand global system is to move heat, to disperse and redistribute excess heat away from the tropics and push it towards the mid-latitudes.
It's like giant planetary air conditioners.
In a way, yes. Acting as a crucial planetary cooling mechanism. It's how the planet tries to maintain a thermal balance. So the more heat that builds up and accumulates in the tropics, like we're seeing now with these persistent record-high ocean temperatures, the greater the potential energy available for multiple strong hurricanes to form, and potentially rapidly intensifying ones if those favorable atmospheric conditions for formation are present.
More fuel means bigger potential fires, essentially.
Exactly. They are nature's way of releasing that pent-up energy.
Yeah.
And the more energy available, the more forceful and potentially frequent that release can be. This underlying principle really ties all these pieces together.
Understanding these powerful weather patterns, these potential shifts and the mechanics behind them, it all relies so heavily on robust scientific research.
Absolute. The foundation.
And as we know, that science is constantly evolving. It's often fiercely debated, and it's always subject to rigorous review and critical examination. It's not static. It's a living, breathing thing.
Indeed. And it's a dynamic process we've actually seen play out quite publicly just recently. There's been significant discussion around how weather science gets interpreted, especially when it comes to informing policy and public understanding.
Right.
For example, a working group within the Energy Department recently put out a report that took some, let's say, contrarian positions on several key weather topics.
Contrarian how?
Well, they questioned things like whether weather change is actually making hurricanes more intense, something highly relevant to our discussion about ocean heat, and also questioned some aspects of the long-term effects of higher CO2 levels in the atmosphere. These positions really diverged quite sharply from the broadly accepted scientific consensus within the wider meteorological and atmospheric science communities.
And that report, I remember it drew a lot of attention and a pretty strong reaction, right? Lots of scientists pushed back hard, citing errors, omissions.
That's correct. It wasn't just a quiet academic disagreement, it became a very public debate.
Highlighting how science corrects itself, I suppose.
Exactly. The response from the scientific community was immediate and substantial. Dozens of highly respected scientists released detailed rebuttals. They meticulously pointed out what they identified as errors, methodological flaws, significant omissions in that Energy Department report.
So a thorough critique.
Very thorough. And this robust response really underscored the importance of scientific consensus, which isn't just opinion, it's built on repeated verifiable evidence and rigorous peer review. But it also showed that critical process of open scientific debate and review playing out.
What happened with the group that wrote the report?
Well, in the face of this widespread critique, the Energy Department eventually dissolved the group. They stated the report had achieved its purpose of catalyzing broader discussion.
Interesting phrasing.
Indeed. But this whole episode clearly underscores a fundamental principle in science. Questions are essential for progress, absolutely encouraged. However, any conclusions or findings must be rigorously supported by solid, verifiable evidence and be able to withstand peer scrutiny.
The evidence has to back it up.
Precisely. This ongoing pursuit of, as one spokesperson put it, a more science-based and less ideological conversation around weather science is vital for maintaining accuracy and public trust.
Beyond these internal debates, though, weather research itself keeps breaking new ground, right? Especially in understanding the impacts of these powerful forces. I'm thinking of some recent studies making incredibly precise connections between specific weather events and these broader long-term trends. It feels like attribution science is getting really sophisticated.
Precisely. It's moving forward rapidly. One fascinating and truly groundbreaking area of research published recently has actually, for the first time, quantified the causal links between worsening heat waves around the world and the global warming pollution coming from individual fossil fuel and cement companies.
Individual companies, not just overall human activity, but specific entities.
Specific entities. This represents a significant leap forward. It's pushing the boundaries of extreme weather event research in surprising and pretty profound ways, because it moves beyond just general statements about human impact towards specific, attributable causation linked to particular corporate actors.
Wow, so actually tracing specific real-world heat waves back to specific companies. That sounds like a monumental task. Almost impossible scientifically. How do they even do that?
It is indeed monumental, and it really speaks volumes about the increasing sophistication of modern weather science and computational modeling. The study looked at a massive data set, 213 distinct heat waves that happened globally between 2000 and 2023. What they found, perhaps not entirely surprising given the broader trends, was that these heat waves got significantly more likely and more severe over that period, largely due to the cumulative effects of burning fossil fuels.
Right. That makes sense. But the individual company part.
That's the really granular detail that's compelling and new. The research used complex attribution models and statistical analyses, and it showed that between the first and second decade they looked at, weather change made these specific heat waves climb dramatically in likelihood, from being about 20 times more likely to an astonishing 200 times more likely than they would have been without that pollution.
20 times to 200 times more likely. That's a huge jump.
A massive jump. It demonstrates a quantifiable and rapidly escalating impact.
And the specifics connecting to companies, that was even more striking. The research found that as many as a quarter of these extreme heat events would have been virtually impossible without the pollution from the 14 biggest carbon majors.
That's the term, yes.
The largest corporate and state-owned producers of fossil fuels and cement. Companies like ExxonMobil, Chevron, even entire nations like the former Soviet Union.
That's precisely what the research clearly shows. This new pioneering work provides these early but really powerful clues about the attributable impact of individual fossil fuel companies across their entire value chain, from pulling resources out of the ground to processing, shipping, and the final burning of those fuels by consumers worldwide.
It draws a direct line.
It meticulously establishes a causal link between their activities and specific extreme weather events. And the study further determined that these same carbon major companies were collectively responsible for half of the observed increase in heat wave intensity since the pre-industrial era.
Half the increase in intensity from just those entities.
That's what the research indicates. It's a potent example of how scientific understanding keeps deepening. It allows us to connect the dots between specific industrial causes and their profound, measurable effects within our global weather system.
In ways we couldn't before.
In ways that were previously unimaginable, really. This kind of research opens up entirely new ways to understand how human activity and weather phenomena interact.
But when the science is this complex and evolving and touches on such fundamental things about our world, it can sometimes become fertile ground for misinformation, can't it?
Oh, absolutely.
And we've definitely seen a lot more of that swirling around weather events lately. Makes it harder for people to know what's real.
Unfortunately, yes. That complexity is often exploited. We've observed concerted efforts to misdirect public attention, to pull focus away from the scientifically established root causes of our current global weather challenges.
Like, what kind of things are we talking about?
Well, for instance, after those deadly floods hit parts of Texas recently, unfounded rumors spread like wildfire about them being caused by sinister weather modification technology.
Instead of, extreme rainfall.
Instead of natural meteorological processes, potentially amplified by weather trends. Yeah. Similarly, there were baseless claims going around that California wildfires were somehow planned by officials to destroy child trafficking tunnels.
Oh, wow. That's way out there.
Truly outlandish conspiratorial narratives. Or that the devastation in North Carolina from Hurricane Helene wasn't the storm itself, but actually the result of a hushed-up dam failure and secret cloud seeding operations.
Just completely fabricated stories.
Completely fabricated, yet despite their lack of any evidence, these kinds of narratives can unfortunately gain traction online and elsewhere.
And these aren't just fringe ideas stuck in dark corners of the web anymore, are they? Sometimes they get amplified, spread through various channels, and actually reach a surprising number of people, affecting public perception and trust.
They are amplified, yes. And that's exactly why it's so concerning. The spread of these narratives highlights the ongoing critical need for credible, science-based information from trusted authorities. It really emphasizes why it's so imperative for you, our listeners, to actively seek out and rely on verifiable research and expert analysis.
Where should people turn?
Established sources like the National Oceanic and Atmospheric Administration, or NOAA as it's often called, when trying to understand these complex weather events and what's truly driving them, go to the experts.
Not just random social media posts.
Definitely not. Without that commitment to factual accuracy, the public conversation can quickly become muddled, polarized, and, frankly, counterproductive, which is the exact opposite of what we need during weather emergencies or when making informed decisions about our shared future.
And that, I think, really underscores why programs like Meteorology Matters are so important, to try and provide that clear, factual understanding and help you navigate through all the noise and complexity.
Trying to cut through it, yeah. So, as we move past that traditional statistical peak of the hurricane season, usually around September 10th,
Right.
and we head into the latter half of September and into early October, we really expect tropical activity to ramp up significantly.
Yeah.
That atmospheric suppression we talked about, the lid of wind shear and dry air, it's forecast to ease.
The lid comes off.
The lid comes off, and all that record warm ocean water is just sitting there, ready to fuel new systems. This shift isn't just speculation. It's based on consistent model guidance and also historical patterns for this particular time of year.
Okay, so for you, our listener, especially if you live along the coast, maybe in the Caribbean, maybe anywhere along the U.S. coastline, what does that expected increase in tropical activity actually mean for your preparedness? What should people be thinking about or doing in the coming weeks and months?
It means that this forecast for increased tropical activity will naturally elevate the risk for direct impacts to the Caribbean islands, to U.S. coastlines. And history provides a very clear, very sobering lesson here. Over 50%, more than half of the entire hurricane season's activity, often occurs after that typical September 10th peak.
More than half happens after the peak. That's surprising.
It is surprising to many, but it's a consistent pattern. This isn't just a statistical fluke. We've seen devastating hurricanes strike late in the season in recent years. Powerful, stark reminders. Just last year, late September, Hurricane Helene caused devastating impacts across a wide area of the southeast Florida, Georgia, western North Carolina, eastern Tennessee. Significant wind and flood damage.
I remember Helene. That was rough.
And the year before that, late September 2022, Category 4 Hurricane Ian delivered that catastrophic storm surge to southwest Florida, along with destructive winds, widespread flooding rain across the whole peninsula. Communities there are still recovering from Ian's devastation.
Ian was just awful. The surge.
Unbelievable. So these late-season storms can be incredibly potent, and they often catch people off guard because maybe the earlier part of the season felt relatively quiet.
Complacency sets in.
Exactly. Complacency is dangerous, so it's absolutely crucial to remain diligent. Stay prepared, especially if you live in hurricane-prone areas. Review your emergency plans now. Have your supplies ready to go. Know your evacuation routes. And please, stay informed through official weather channels like NOAA, your local emergency management trusted meteorologists.
Don't let your guard down just because it's past the peak.
Absolutely not. The season is far from over.
Okay. Beyond the immediate concerns of the hurricane season, though, we're also starting to get a much clearer picture of what winter might hold, right? There's increasing talk, growing anticipation around the development of La Niña. That's another major global weather player, isn't it?
That's absolutely right. Another big piece of the global puzzle. The National Oceanic and Atmospheric Administration's Weather Prediction Center, NOAA, they recently increased the odds of La Niña developing this fall. Quite significantly, actually.
How much higher are the odds now?
There's now a 71% chance it will appear between October and December. That's up about 20% just since last month's forecast.
71%. That's pretty high confidence.
It indicates a growing and pretty robust confidence among forecasters that this global pattern will emerge and likely influence our weather as we head towards winter.
Okay, so for folks who might not be familiar with the term, what exactly is La Niña? How does it fit into the bigger weather picture? What's going on there?
So La Niña is one key part of this significant three-phase global weather cycle called the El Niño Southern Oscillation. You might hear it called ENSO for short.
ENSO.
It's a totally natural phenomenon. And it's characterized by cooler than average surface water temperatures across the central and eastern tropical Pacific Ocean, right along the equator out there.
So the Pacific cools down near the equator.
Exactly. A distinct band of cooler than average water forms. And this shift in ocean temperatures in the huge Pacific Basin then has this profound ripple effect. It influences atmospheric circulation patterns, including those high-altitude jet streams across the entire globe.
So cool water in the Pacific changes the wind patterns way up high.
Fundamentally, yes.
Yeah.
It reorganizes the major air masses and the storm tracks, especially across North America. It's a major driver of seasonal patterns.
Okay, so how does that cooling in the tropical Pacific, this La Niña, typically affect our winter weather here in North America, maybe elsewhere too?
Yeah.
What are the historical patterns? What kind of impacts might we anticipate from a La Niña winter?
Historically, La Niña typically pushes the polar jet stream, that fast-flowing river of air high up that steers weather systems.
Right, the jet stream.
It pushes it significantly further north than usual during the winter months. And this shift, this displacement of the jet stream, fundamentally changes winter weather across the continent.
How so? What does it mean for rain and snow and temperature?
Generally, it can produce wetter and colder weather than average in some areas. Particularly, it often leads to more snow and colder temperatures in places like the Pacific Northwest, up into British Columbia, and across the northern Rockies.
Good news for skiers in those areas, maybe.
Often, yes, it can bring abundant snowfall to those regions. Conversely, though, La Niña is often associated with drier and sometimes warmer conditions further south. It can increase drought risk across the southern tier of the U.S. states like Nevada, New Mexico, Arizona, plus the southern half of California often see drier conditions.
So wetter, colder north, drier, warmer south, generally speaking.
That's the general tendency, yes.
Yeah.
It's a significant influencer, especially for precipitation and temperature patterns across North America.
So it's not like a universal cold and snowy forecast for everyone then. It's more like a redistribution of the weather, right? Some areas get wetter and colder, others drier, maybe milder.
Exactly. It reshuffles the deck.
And I assume the strength of the La Niña matters too, like how strong the cooling is in the Pacific. Does that change the impacts?
Absolutely. That's an extremely important nuance. You're spot on. This global pattern is definitely modulated by the strength of the La Niña event. Generally speaking, the stronger a La Niña is, the more reliable and consistent its typical weather impacts tend to be around the world.
Okay. And what are they forecasting for this potential La Niña? Strong, weak.
Well, right now, forecasters are anticipating a weak La Niña to develop this fall.
Weak, okay. So what does that mean for the forecast? Less certain.
It means that while it certainly loads the meteorological dice in favor of those historical patterns we just discussed,
Right.
it doesn't guarantee specific outcomes for every single location or every single day. Weather's always complex. There are numerous other regional and global factors at play each winter, things like the Arctic Oscillation, other teleconnections that can mess with the jet stream patterns too.
So La Niña isn't the only thing driving winter weather.
Never the sole determinant. But even a weak La Niña is a strong predictive tool, especially for those broad precipitation patterns. It gives us a valuable early outlook on what the coming winter might hold.
A key piece of the puzzle, but not the whole picture.
Exactly, a crucial piece of a very intricate global weather puzzle. Hashtag outro.
Wow. Okay, what a journey we've taken today. Through the current quiet in the Atlantic, but also the brewing potential for a very active rest of the hurricane season.
Definitely something to watch.
And then into the fascinating science shaping our weather. From that record warmth deep in the Gulf of Mexico hinting at a potentially volatile period ahead.
That deep heat is key.
To the vigorous debates within weather science that, ultimately refine our understanding. And now looking ahead to the emerging La Niña forecast for winter. It's just so clear that meteorology matters deeply and profoundly in our daily lives.
It really does. And understanding these intricate systems, it helps us not only appreciate the immense power and complexity of nature, but it also underscores the vital role of ongoing research, that science helps us navigate this ever-changing weather landscape.
Absolutely.
Stay curious, stay informed, and always, always stay prepared for whatever the atmosphere and oceans might bring our way.
Great advice. And thank you for joining us on this exploration with Meteorology Matters. We really hope you've gained some valuable insights today. If you want to keep up with the latest weather developments and get more expert analysis, make sure to follow meteorologist Rob Jones. You can find him on Instagram at meteorologist, that's Meteorologist.
Yep, that's me.
On TikTok, he's at TV Meteorologist. And over on YouTube, you can find him and the Meteorology Matters podcast playlist just by searching for Rob Jones Hurricane.
Lots of updates there.
If you enjoyed this dive into the world of weather, please do us a favor. Like, follow, comment, and rate Meteorology Matters wherever you get your podcasts. Your support truly helps us bring you more of these important conversations and keep exploring these critical topics.
We appreciate it.
So, as we watch for those shifts in the tropical Atlantic and we look ahead to a potential La Nina winter, here's maybe a thought to mull over. How do we, as individuals, as communities, as a whole global society, how do we best prepare for an evolving weather landscape when the very science that informs us is sometimes under such intense scrutiny or even actively challenged by misinformation?
That's a big question.
It is. It's a question that goes way beyond just forecasts, doesn't it? It gets into the very fabric of our collective future. Something to think about. Until next time, stay safe and keep looking up.